Imagine pointing the most powerful telescope in human history deep into space and finding something that shouldn't exist. That's exactly what happened when the James Webb Space Telescope, JWST, found galaxies so old and massive they seemed to defy the known laws of cosmology. In the earliest moments of cosmic history, just a few 100 million years after the Big Bang, we expected to see baby galaxies just forming. Instead, Webb has turned up what some are calling universe breakers, ancient galaxies as big as the Milky Way or older than the universe itself. Did we just break the Big Bang? This is the James Webb Paradox. To understand the astonishment, let's set the stage. According to the standard cosmological model, lambda CDM, our universe began about 13.8 billion years ago in a hot Big Bang. In that model, stars and galaxies form gradually over time. The first stars pop on around 100–200 million years post-bang, and even the first galaxies should be tiny clumps slowly growing. For most of the last century, this timeline made sense, but JWST's infrared time machine is now probing the universe's first 1% of time, and what it's seeing is wild. Early on, Webb smashed records. In 2025, it discovered a galaxy named MOME Z14 that existed just 280 million years after the Big Bang, a cosmic newborn in human terms. MOME Z14 is the most distant object ever seen, pushing the frontier closer to the Big Bang. For context, as an astronomer pointed out, sharks have been around on Earth for a longer time span than this galaxy existed. In just a few years, JWST beat dozens of distance records, revealing galaxies at earlier times than any telescope before. All that sounded thrilling, but still within cosmic norms. We expected new record holders. That's science. But then came the eyebrow-raising discoveries. In 2023, scientists reported 6 massive galaxies only 500 and 700 million years after the Big Bang. They contain tens to hundreds of billions of solar masses of stars, rivaling today's largest galaxies. Under our models, the universe should still have been an infant, full of tenuous clouds, not already hosting Milky Way-size monsters. One lead researcher said, "It was just crazy that such galaxies could exist so early." Another called them universe breakers, because their mere existence challenges the standard story. If true, it's like finding a fully grown adult where only a newborn baby should be. And it gets weirder. In July 2024, a preprint analyzed JWST data from galaxies at redshift 8, when the universe was only about 600 million years old, and found something almost mind-boggling. The stars in some of these galaxies appeared to be 900 million to 2.4 billion years old, ages that exceed the 600 million year age of the universe at that time. In other words, it implied the stars formed before the Big Bang. It's like pulling out a birth certificate that predates your birthday. This analysis suggested that if these age estimates are right, either the galaxies grew in some exotic way or our cosmic timeline is off. The authors even hinted that non-standard cosmologies might be needed, or at least a rethink of cosmological assumptions. Some have taken this to sensational extremes. Headlines asked whether galaxies could be older than the universe, or if JWST means we must rewrite cosmology. But scientists themselves urge caution. The result depends on complex modeling of starlight and dust. The research lead admitted that while this finding is very disturbing to astronomers because it makes no sense that stars are older than the cosmos, they also stressed it requires independent confirmation. In fact, he noted that we wouldn't throw out the Big Bang entirely, but might need to rethink some of its structure if the issue truly lies in the cosmological model. So, What does it mean? Could the universe actually be older than 13.8 billion years? Some have pointed to alternative theories. For example, the RH equals CT model assumes the universe expands at a constant rate instead of accelerating. This tweak would lengthen the implied age at a given redshift, potentially fitting those old star populations. In such a model, the cosmic timeline stretches out, but it's a minority view. The mainstream lambda CDM model, with dark energy driving accelerated expansion, is still our best bet. Every few paragraphs, JWST's findings have been a roller coaster. One moment, it looks like we might finally see the first generation of pristine, hydrogen-only galaxies. The next, it's as if the universe is a chaotic surprise party. In fact, a recent study of hundreds of young galaxies between 800 million and 1.5 billion years old shows that the typical early galaxy is messy and turbulent. Exactly as traditional theory predicted, only a handful were the gargantuan outliers grabbing headlines. Those large, red objects could be the exception. Or even misidentified objects, like a bright quasar masquerading as a galaxy. Some researchers are finding that known physics might explain away the paradoxical part. For instance, astronomers in a new study re-examined some of those massive candidates and discovered hidden culprits. Supermassive black holes lighting up gas in the galaxy. If a monster black hole lurks in the center, it heats gas and makes the galaxy appear extra bright and bulky. Accounting for that, the galaxies aren't truly as gargantuan as first thought. As one researcher put it, none of them are so massive that they break the universe after you correct for these effects. Another possibility is a dust redshift trick. Cosmic dust can redden a galaxy's light, making a galaxy at moderate distance look redder and older. Like an optical illusion, some early JWST galaxies might instead be nearer, dusty galaxies masquerading as behemoths on the edge of observable space. University of Texas astronomers calculated that if they tried to change the physics of the Big Bang, for example, boosting early density fluctuations to explain all these hulking galaxies, they'd predict even more smaller galaxies than we actually see. In short, Munoz and colleagues found you can't just tweak the universe's expansion enough to fix the problem without breaking other observations. Despite this, there are still surprising statistics. JWST surveys are turning up about 100 times more bright, high redshift galaxies than were expected based on older Hubble observations. It appears the early cosmos is richer in galaxies than our models predicted. Researchers found that in one deep field, Webb detected 100 or more bright galaxies in that very first half-billion-year window, far above the count derived from previous telescopes. Even if each isn't as massive as it looks, it shows stars and galaxies lit up quite early and often. So where does that leave us? Have we broken the Big Bang? The consensus is still no, not yet. The Big Bang theory, as the origin of cosmic expansion, remains robust, supported by multiple lines of evidence. Cosmic microwave background, nucleosynthesis, expansion measured by supernovae, etc. What JWST is telling us is that our story of how the universe evolved may need revision. If galaxies formed faster or by different processes, for example, runaway star formation, lots of mergers, exotic dark matter, clumps, it would mean adding new chapters to cosmic history, not erasing the origin. However, we must be honest. This is one of the most exciting challenges in cosmology. It's possible that some unseen physics is at work. For instance, if dark matter or dark energy behave differently at high energies, it could subtly change how structure grows. Or maybe the distribution of matter at the very start was a bit more uneven, seeding faster growth in some regions. None of these ideas are confirmed, but scientists are running simulations to see if under any reasonable tweak, the timeline can be saved without throwing out the whole theory. What's for certain is that further data will decide. Spectroscopy, splitting the light from those ancient galaxies, will pin down their redshifts, and thus true distances and ages, more accurately than broad photometric measures. If follow-up observations confirm that these galaxies are indeed as old and massive as they seem, our cosmological models will have to accommodate them. If they turn out to be closer or influenced by black holes and dust, the paradox will fade. Even the JWST team cautions that we should not jump to rewriting textbooks until multiple lines of evidence converge. Meanwhile, there's a silver lining for astronomy buffs. These mysteries make the universe more interesting, not less. Every generation of telescopes has overturned something. Hubble once found that the universe is not static, but expanding. WMAP and Planck refined the precise age of the cosmos. Now Webb is telling us the early chapters might be rewritten. It's a testament to science that, when fresh data come in, no theory is sacred. Everything is questioned and tested. In the end, we have to remember, paradox doesn't mean proof. It means puzzle. The James Webb Telescope has certainly shown us evidence that something unexpected is happening in the first 500 million years of the universe. Whether that leads to a paradigm shift or just a better understanding of galaxy formation, it's a thrilling time to watch. One way or another, our view of cosmic history is changing in real time. What do you think? Did JWST just break the Big Bang? Or are we just sharpening our cosmic map? If this mystery fascinates you, hit the like button and subscribe for more cosmic deep dives. Leave a comment below on what you think is behind these ancient galaxies. Stay curious. The universe is bigger and stranger than we ever imagined.